my God, the last session for the day. It's amazing, and it's about data architecture. It's a perfect appetizer for the party tonight. I'm just gonna get a feel of the room before I introduce myself. Who here is considering himself a data person? Like data engineer, data scientist? Awesome, awesome. So there's gonna be stuff for you guys and also for the rest of you, so don't worry about this. My name is Josef Goldstein. I'm working in a company called Wix. If you're not familiar with us, we are a platform for building websites and online businesses. And in Wix, I am the R&D manager for the group responsible for Wix's data engineering and analytics platform, or the way I like to call it, big data platform. Now, this is not a talk about Wix. I will be talking about how we're implementing some of the concepts that I am talking about in Wix, but we are hiring. So, like I said, it's a talk about data architecture, and usually when we talk about data architecture, we think about two separate concepts. So we have, on the one hand side, the operational plane. The operational plane is basically all the data that we're using for our operational systems, the databases that we use for our microservices, right? The stuff that moves the business. We're not going to be talking about that. There's enough talks about that in build stuff. We are going to be talking about the analytical plane. The analytical plane, where all the fun stuff happens, but what does it actually mean, right? So like any modern company these days, talk about data analytics. Every modern company these days want to be data-driven. Anyone here works in a data-driven company? Okay. Anyone here knows what data-driven means? Less hands. That's what I thought, right? So just kind of explain the concept of like why do we need to be data-driven? Why do companies want to be there? Let's think about a business, right? So let's imagine that we have a store, like a real store, like a brick and mortar store. I'm not talking to Amazon here, right? And we're trying to understand how to run the business, right? So how do we do that, right? We see the people going in and out of the store, like we can see what they're looking at, what they're buying, what they're not buying. We can, ask them like, what are you interested in? What would make this store better for you, right? And that's usually how we get like the instinct of how we should run the business, right? Which items we should sell more, which less, when we should open the store. But when we're running an online business, we don't have any of that. Now, an online business doesn't necessarily mean in an online store, like the ones that you can build on Wix. An online business is basically any type of business that's just run online. It doesn't have a brick and mortar place. They can be any type of SaaS business, right? Who here works in a SaaS company that sells cloud products, right? So all of these are all online businesses. And then it comes the question like, okay, how are we making decisions on what we're doing in the business, right? Because by default, we're blind, right? We can't just go to each one of our users and ask them, like, did you like this? Did you like that? No, did you no, that? And also, it amplifies when we're talking about online businesses because scale is different in online businesses, right? So if I have a physical store, if I'm lucky, I'm going to have several hundred people coming in. That's how this business works. But when we're talking about online businesses, we're talking about millions. If we're talking about social networks, we're talking about billions, right? We can't just go and ask a billion people what did they think today about our product so we can build it better tomorrow. So that's the idea of data analytics. The idea is, let's not go with blind feelings, even though that could be nice. Let's use data to make decisions. Let's create eyes for our business through data. Which brings the first question, where do we get that data? Right? So the business, if we're talking about online businesses, SaaS product, cloud companies, the business is happening somewhere, right? So it's happening in users' browsers. It's happening in all kind of microservices, right, that are running all kind of transactions and API calls and whatever. It's happening in all of our operational databases, right, where we store all those transactions, all our entities, right? But then comes the question, okay, cool, I understand, but that's the operational plane. You said you're not going to be talking about that, right? So how do we get that to the analytical plane? So this is obviously, talking in broad terms, but like how does it usually work in most companies today, right? So on the one hand side, we have the developer having the best time of his life. And he or she are working on the operational system, right? And the operational system is going to be storing that data either in some kind of operational database, it can be whatever, or some awful third party. And on the other side, we have the data engineer or data scientist or machine learning engineer or data analyst, whatever. And they want the data in their analytical data store because they want to answer those business questions. Manager want to do what to do. So how do we do that? So, most straightforward, what do? Copy the data, right? Kind of straightforward. Ideally, we're not going to do it with the actual database. We're going to create a replica, and we're going to do what is usually considered or called an ETL. So ETL is short for extract, transform, and load. We're going to write a lovely script, and once in a while, that lovely script is going to go to the replica of the database, and it's going to copy it, and going to shove it into our analytical data store, like whatever that is. And we're going to use that for analytics, right? Fun. If we are even more cool, we'll be using something called the CDC. Anyone here familiar with CDC? Cool. So for those of you not familiar with that, CDC is short for Change Data Capture. It's a standard that most databases implement nowadays, which create an event log of all the changes that have happened inside the database. And essentially, it can give us the exact same thing, only in an event-driven way, right? We're going to get updates in near real time every time something happens in the database, and we can just stream those, maybe do some transformation, maybe not, who knows, into an analytical data store. And this is how data operations look in most companies today. But there's a problem with that, right? This is an implementation detail of our operational system. Like, this data was not meant for analytics. Like, that developer didn't expect anyone to go behind his back or her back and get the data. What actually we've built here is a data recycling center. And I truly believe that the way analytical data works today in most companies is not really what we would want it to be. It's more of a data recycling center. By the way, can anyone spot the data engineer in this picture? Let me help you. Right there. So what's the problem? What's the problem here, right? So we are taking data that was not meant for analytics. We are taking the exhaust, the byproduct of operational systems. We sometimes talk to the developer, maybe not, YOLO. And we are trying to kind of smoosh it and reuse it for something that it was not built for to begin with, right? So what are the issues that we can get from living in this paradigm, in the data recycling center? So the first issue is that we don't actually have any contract between the data creator and the data consumer, right? So we have the developer or the team that owns a certain domain, right? A microservice or a set of microservices, and they're generating data. That's data that is important for the business. But there is no set contract between them and the consumer of the data engineer, the data analyst, right? And what does it mean? It means that today I take the data and there's a field there, and that today it's an integer, and after that it'll be maybe a string, and the day after that, maybe a cat. And if you think that cat is miserable, you haven't experienced a pipeline breaking on a Friday afternoon. That is miserable, right? And it all has to do with the fact that this data has no guarantees. There is no set contract, no agreement between the developer and the data consumer. So that's issue number one. The second issue is, when we're building things in pipelines this way, right, we're actually not documenting how the data looks at any point in a given time, right? We don't know how the schema of the data looks. The only way to know how the data looks is to read code or SQL, which some might argue is code as well. The data and the way the data looks becomes implicit. It becomes lore. What we want to do is we want to make it explicit, right? We want to make it descriptive and declarative, right? The third problem, and this is kind of more nuanced, is what I like to call the raw data fallacy. So what does the raw data fallacy mean? People in the world of data and the world of analytics have kind of grew to believe that if we take all the data that exists in our systems, in our operational systems, in our company, this is going to be good enough to answer all of our business questions. But that's not necessarily the case. Let's imagine that what we want to do is answer a business question that has to do with geolocation, the country of origin of our users. If the data that now we're copying from the operational systems does not have any geolocation information or information that we can derive geolocation information from, like an IP address, the data is useless. We cannot use it. It doesn't matter how much we will copy it, right? And that leads to the fourth problem. Everything that I talked about until this point is usually ad hoc, right? There's a new microservice, new database. Okay, we connect to this. Is this a Mongo? No, it's a Mongo. Oh, okay, it's a SQL. We do it like that. And then continuously to break, right? Because that integer turns into a string, turns into a cat. We need to fix that one each one by one, right? That doesn't scale well. So when we think about, modern companies, we think about cloud scale. We're talking about tens and thousands of microservices, right? We can't just do this every time we spin up a new microservice, right? It doesn't scale. And the sad part about all of this is that this is not how data looks for most of the software world, right? When you think about how data integration looks in more traditional integrations between systems, things like service APIs have been here for years, right? What is a service API? It is an interface for interrupting data between systems in an agreed manner. So what we want to do is we want to do the exact same thing for us. Why can we not do that? So if we look at where the problem is basically everything that's happening between the red line, right? So we are here, and basically what we're trying to do is to infer some meaning from data that was originally not meant for the thing that we're trying to do. What do we want to do? Because everything in the middle, that's a danger zone. We want to eliminate the danger zone. We want to shift left. We want to move the responsibility of defining the data that we use for business analytics all the way to the beginning, all the way to its inception. Essentially, what we want to do is we want to turn analytical data into a first-class citizen in our product. Why? Because we use that to make the decisions that we're doing to build our product. So we're going to talk about today about how are we going to create the concept of a data contract, right? So what is a data contract? We want to create a certain guarantee, a certain agreement between the creator of a data, right, within a domain, and the consumer of the data within the domain. We want to give the same guarantees that we would give, for example, over an API to our data integration layer, right? And ideally, we want to do that in an event-driven manner. Why? Because we want the data fresh. We want to keep it up to date, right? So how does it look in practice? Okay, so let's take, again, we have the developer that are having the best time of his life, and we have the data engineer. So what we would want to do is, even before we want to write a single line of code, we would want to define first the data contract. And the data contract is a way for that developer to explain what is the data that the domain that he or she are managing going to expose to the world, right? Because again, ideally we're working in a domain-driven manner. And once we have that defined data contract, and that should be what kind of entities do we have in our system, what kind of events do we have in our systems, we want to take all that information from all the microservices, from all the domains that we have in our company, and we want to put it in a singular metadata registry, right? We want to catalog everything in one place. Why? Because that is the place we're going to go and look for all the data that we have in our organization, right? And then what do we want to do? We want to automate things, right? So basically, we don't want to continue doing things ad hoc anymore, right? We don't want to, every time that there's new microservice, new domain, we want to write it. No. We want to take the information that we can have in this registry and ideally automate the process of taking this data from one side to another, right? And this is a process that's called metadata-driven ingestion. We want to use the metadata of how our contracts look to drive our ingestion process. Why? Because we don't want to waste our time on boilerplate. We want to do fun stuff. Yeah, that's right. Huh? Got your back. So, like I said, I'm going to talk about two strategies for domain-driven data contracts that we are implying in Wix. These are not specific for Wix. You will be able to do it yourself, and I will also talk about how you could do it yourself using the technology that you might be able to find open source. So don't worry about that. So, first strategy, domain events. Everyone here heard about domain events? Okay. So this is really new for some of you. Cool. Domain events are actually not a very new concept. So this is a term, or this is a quote by Martin Fowler from about a decade ago. So domain events are events which capture the memory of something interesting which affects the domain. What does it mean? So let's say that I have, within my domain, some kind of a domain component, right? Every time something interesting will happen within the domain this component manages, and this component can be a microservice, it can be a batch script, it can be a serverless function, right? It can be an abstract thing that manages a certain domain within my business. Every time something interesting will happen within this domain, I'm going to tell the world about it, right? And that thing can be, an entity change. So let's say that I have a microservice that manages a certain business entity. So every time I create a new instance of this entity, every time I update one, every time I delete one. But it can be also like a business event that have happened. Something expired. I got a callback. I got something, right? And the idea of these events, they are a way for us to tell the world what is happening within our domain while keeping the world decoupled to us. So essentially, if we have another domain component from a different domain, and they want to understand what's happening in my domain, maybe they want to react to it, all they need to do is to subscribe to these events, consume them, and then continue to work on their side, right? So this is a very basic concept of event-driven architecture to create decoupled async communication between domain components. But we want to use the exact same concept to create a data contract between the domain owner and our data analytics part, right? So essentially, these events that are published by our domain components are de facto now the data contract, right? Because the domain components tell us that this is the type of data that's going to be emitted. So how does it look in real life, right? Let's take it again to a real story, right? So let's say that we're taking this to the world of e-commerce. And we have, again, the developer, such an amazing developer. And now we want to develop a shopping cart microservice, right? So we have a new thing. It's amazing. We just thought about it. It's called a shopping cart for our e-commerce website. And we want to build a microservice that manages this domain, right? So what's the first thing that we're going to do? So the first thing that developer is going to do is to define the service contract. And in Wix, this service contract composes many things, but primarily it is composed of three things. So the first one are the domain entities, right? These are the entities that are managed by this microservice within the domain. For example, the entity of the shopping cart, right? And this will explain to us how this entity looks, like what are the fields that exist there, what are the semantic qualities. The second thing it will describe would be the domain actions, things that you can do, that you'll usually will translate into APIs. And the last one would be the domain events. What are the events that this microservice is going to emit whenever something interesting happens within the domain? Let's say a new shopping cart is created. So the way we're doing this Wix, we're doing it using protobuf. So the way it looks is like this, right? So we describe event. So we have an event for the cart created and another one for the cart being completed, right? The act of finishing the shopping cart. And then we have the domain entities, and we're reusing it throughout that. And now the interesting thing about this is very descriptive, because what we're doing here, we're actually defining all of the data that exists within our business. We're saying, okay, we have an event that says that a shopping cart was created, and this is the information that we're going to have over it. And by adding field-level documentation, we're going to understand, okay, this is what this field means. But we can take it further, right? So we can say, okay, so this ID, the cart ID, that actually is supposed to be formed like a UUID. So I will add this semantic information because later it will be important to understand if this is based on how the data should look or should not, and I will know how to treat it. But we can take it further into even more semantic definition and saying, okay, let's say I have the buyer information, right? The person that is actually now holding the shopping cart. I'm going to have a field for the first name and the last name of that person. But people here that have some sensitivity to data know that first name and last name, that's dangerous data, right? That's private user information. So we can say this is private user information. If you're going to be consuming this data based on this contract, think about it. So maybe you want to encrypt this data, maybe you want to emit it completely. Maybe you're going to use that to define whether you can even consume this data or not, right? Because this data is now sensitive. So we define our data contract, right? What's the next thing that we're going to do? So now we know we have this microservice. This is the data that's going to emit. What's the next thing? So the next thing is to put in the repository, right? So we created a business schema registry. That is the way we describe it. But the idea is this is basically a service that holds a catalog of all the service contracts of all of the services that exist in the company. So for example, in Wix, we have about 2,000 microservices. So we have about 2,000 contracts here for all the services. And that encompasses basically all the data contracts that exist within all of the domain within Wix. So what we can do with this, though? So first thing we can do with this is to create a glossary, right? Very simple. Like, I want to understand what kind of data exists and where, right? So we can take all these schema definitions, in this case in protobuf, and then generate documentation based on it that will create a catalog. And it'll look something like this, right? So if I have the shopping cart story, right, and I have the event that says shopping cart created, and I want to understand, okay, what kind of data can I get? So like, ta-da, right? So you can see all the fields that exist. You can see some samples of the data. And then later, if you decided you actually want to consume it, well, here's the Kafka topic where this data exists, right? So we are using Kafka as a streaming engine for asynchronous communication, right? And, you know, in case you want to know some more information, because everything starts from a domain owner, right? a team, ideally, not just a developer, there's always an owner you can talk to, right? And that's the team that's responsible. It's the owner for this domain contract. So what's the next thing we can do, right? So, okay, this is fine, this is awesome, but we want to get this data now into our analytical system, right? And we want to do it in a way that's repeatable, right? Because like we said, we don't want to repeat ourselves, right? We want to do it automated. So now only thing we need to do is to create a pipeline, and that can be like a bespoke pipeline or an automated one. They can just say, okay, I will go to this registry, and I want to get all the events that are to do with our shopping cart. Why? Because I want to maybe create a funnel to understand what is the journey that a user go through when they're shopping in our company, in our product. Why? Because I want to understand what I need to improve, right? Because I want to sell more. So all I need to do is to go to the registry, say, please give me all the events that exist for the domain entity, which is the cart, and please start consuming them into our analytical data store, which in our case is a data lake, right? Easy peasy, boom, table, amazing, right? And because this is all event-driven, this data is actually updating in real time, right? So every time a user is going to be creating a shopping cart, there's going to be a domain event emitting from the microservice that will immediately go through the pipeline, boom, and land itself into our table, right? And then we can have a table that says, here are the shopping carts, here's what happened, this one was created, this was abandoned, and what do you know? Ta-da, amazing. Amazing. Now we know what's happening. But why we like, there's a problem here, we're not selling well, right? We're losing a lot of customers, right? But we'll get back to this later. So how does it look in terms of architecture, right? So it's pretty straightforward as much as you would imagine it. So again, we have the microservice. In Wix, usually the microservices are written either in Scala or in TypeScript. And that microservice, as it builds as part of the CI/CD part of it, publishes the data contract, right? The service contract. And if it's a new service, it's a new service contract. It's an updated one, then it's a new version of that service contract, right? And from that point on, once that service is up in the air, you can start sending all the events over Kafka, which, like I said, that's our streaming engine. And at that point, anyone can consume these events. In our case, our streaming ETL is going to consume it. In our case, that one is built on top of Spark Streaming. And what are we going to do with the data? So first, we're going to automatically, go to the registry, understand how the data looks. Okay, now I understand how it looks. Now I know how to process it. We're going to do data verification, right? That field should be a UUID. Let's make sure it still is. That data is PII. Maybe we should not save that, right? And maybe do some enrichment, right? Additional data that we need, and then write it down to our data lake. So in our case, we're managing our data lake in AWS S3 using the Iceberg format, but really, you could use anything. So, very, very cool. But then comes the question, okay, fine, Wix, but how am I supposed to do this myself? So the first thing that I really, really would suggest looking into is Async API. It's a relatively new project, but it's been gaining momentum in the past several years. And it is aiming to be what Open API became for Service API, for RESTful API. So essentially, the idea is to create a non-language specific standard, an open standard, for defining those event-driven data contracts, right? And the beauty about this is that, first of all, it's portable. So it's portable between different languages. You can get very cool things right out of the box, like documentation generation. Basically, as similar as OpenAPI will create Swagger documentation for you. You can get code generation, right? So basically, you'll generate your domain model entities from that, and you can use them in your service. And if you're using specific schema registries, you can even get, for free, schema registry registration. Basically, once the service goes live, it registers its schema, right? So whether you choose to do that or not, you will need to choose some kind of a form to define the schema of your contracts, right? So we chose to go with protobuf. You can go with Avro. You can go with JSON schema. And then you will need to have a certain registry in which to register all these contracts, right? All those event-driven data contracts. So if you're using Kafka, the kind of obvious place to go to would be Confluent Schema Registry, but really there are other options out there, and you can always do what we did, which is, just do it yourself. Cool. But if you remember what I said, we had that lovely funnel, and we were losing a lot of customers, right? Like it started really nice, and then very few people were buying it. And okay, but we need more information because I don't think that was enough to understand what we're supposed to do with it. And this is where the second strategy comes into play, right? So domain events are very comprehensive when it comes to things that are happening in the business, usually in the back end, right? So usually you won't find domain events happening in the front end, right? Because it's more of a back end type of thing. But in reality, for a lot of systems, a lot of the things that are interesting are happening on the user's browser, actually. Right? So if we're talking about the shopping cart experience, right, a lot of the stuff happening on, okay, where did the user navigate to our website from? How many times did the user go into the shopping cart page, right? Things that don't usually create or don't necessarily create a footprint in our backend services. So that's data that we're just not tapping into. The other problem is what I mentioned before about the raw data fallacy. Yes, we are getting all the information about what's happening in the shopping cart domain. But is that enough to answer all of our business questions? Let's say what we want to do is to create a funnel that depends on where did the user come into our website from. That's not necessarily information we have in the backend, right? So for those cases, we need to go bespoke. We need to create data that is not starting from the domain and we are using it, but starts from our analytical needs. So the way I like to describe this is analytical data instrumentation. So I don't have a fancy quote, so this is me. Predefined business intelligence events and telemetry explicitly collected at the source. So what does it mean? If before we built our domain component, and while building it, we defined our data contracts and our events, the domain events, in this case, we start in the opposite way. Actually, we start by asking questions first. We're asking the analytical questions we want to ask. Let's say that funnel that we want to build. What data would we need to be able to answer that question of where are we losing all of our customers? All right? So the data contract actually starts before the domain component. Once we have that data contract, we're going to the owner of the domain component saying, look, this is the contract that we expect you to fulfill, so we will have the data that we need to do analytics. And this is where the instrumentation comes into play, right? So the idea is the domain owner, the domain component owner, now instruments specific data that generates the events that we would need to consume for analytics, right? So how does this work in practice, right? So again, we're starting not at the developer this time, we're starting at the people that are asking the questions. So that usually would be some analyst, some product manager, maybe your boss, right? And now what we want to do is to define what events and what data would we need in order to answer the question that we want to answer, right? So in our case, the way we would do it is using a system where you can go to the system and say, okay, this is the data that I would wish that I get. I want this event and that event and this event and that event, right? So we actually build our own proprietary system to do that. We call it BI events, BI catalog. We are very, very proud of it. It looks something like this. But essentially, it's the same idea that we had before, only starting from a different place, right? So first we have the domain, right? And within the domain, we have the list of events that we would wish to have in order to do analytics. And then inside of it, we do like all the rest of the stuff. We explain, what does this event mean? Why do we need it, right? What are the fields that we need and what is the semantic quality of each one of these fields? Basically, a full description of all the data that we wish we only had, right? So good. So now we have a definition of all the data we only wish we had to do analytics. What's the next step, right? The next step is actually getting this contract to be instrumented inside the actual code that is running in the system, right? So the way we do that is by generating an SDK. So for example, if we're talking about things that are happening on the client side, things that are happening on the browser, so we'll be generating an SDK in TypeScript, and that SDK is built purposefully for instrumenting the exact data that we defined before in that catalog, right? So it's the exact opposite of what we've done before. And now the developer, all the developer needs to do is to take the SDK that we gave him, write the line of code that says, please send the event of I've navigated into the cart page, and got everything we need, right? And the way it works in Wix, because we love our developers, we even give them like samples of code, and we give them like code for unit testing that. And obviously, you have to have the entire autocomplete type of experience, because we love those developers, right? But basically, this is how it looks. The developer goes, starts working on whatever, like the shopping cart page, and takes importing the SDK library, and add the line of said, shopping cart page navigated, and then start adding the information. Because we're using TypeScript, it's all well typed, so we can roughly trust the data. Awesome. So what do we do now? We've instrumented our code. So now our code is actually sending all the data that we need. And from this point on, we're kind of doing the same thing we've done before, right? We have a pipeline. That pipeline goes back to our registry and asks him, what kind of data we have? How does it look? It looks like this. oh, awesome, I will start consuming it. So it starts consuming all the data automatically, and obviously, as things update, as new events are created, as schemas updated, it updates as well, and eventually, everything ends up in the analytical data store. Amazing. And this is all in real time, right? Because when a user clicks a button, an event is shot, and we'll get the data in near real time. And then we can get amazing. Right? So it's a better way to understand kind of where we're losing our customers, right? So how does it look in terms of architecture? So pretty straightforward when you think about it, right? So obviously, we already went through the part where we defined all the events that we would want, and we generated these SDKs. And now a developer took that SDK and embedded it into the application. If it's a client-side application, we will be sending these events over HTTP into a dedicated collector. And if it's a backend if it's a backend service, then we will just use a log collector. And eventually, we will be funneling all this data into a Kafka topic, or Kafka topics, rather. And then from this point on, it's a very similar type of ETL. In this case, we're using Kafka streams and Spark streaming. We will continuously collect the schema definitions and the data, essentially the data contract that we defined, back from the catalog. And we will use it to later create the tables that we want in our data lake. Simple, pretty simple. Now, obviously, this is built on a lot of proprietary stuff that we build ourselves. Brings the question of, okay, so how do you build this yourself? So here's actually a good answer I would say. There are platforms that are built for doing these type of things. I'm not affiliated with any of those. Some of those are open source. Some of those are very much not open source. But I would really highly suggest that you look into those if you are interested in doing these type of things. Cool. So, zooming out for a second. We were trying to take us from where we are today and where systems exist today in the data recycling center and taking us out of there. But what did we accomplish? So what we did is we took the idea of analytical data and we turned it into a first-class citizen. How do we do that? We did it by defining a contract. But more importantly, we moved the ownership of this contract as far as we can to the left. We actually turned the ownership over the creation of analytical data to the developer side, to the domain owner side, right? And by doing that and creating a set language for defining all these data contracts, it enables us to put everything in one place, which is cool, right? We're able to know how the data looks even before touching it, right? We're able to view it. We're able to find it, right? Think about a big company. And then, most importantly, we were able to automate everything, right? Because once we give all those contracts through an applicative manner, through an API, it's very easy to automate something that someone else would usually do manually. And that's something that can help us scale this into like a big company and a lot of microservices. And then once we have data that we can trust, right? Because this contract actually has a meaning, right? Because this is the same contract we're using for our APIs that we're giving to our customers, so we can't just break it, right? We can trust it. Then the data engineer or the data consumer on the other side can spend most of their time doing fun stuff instead of just chasing kittens or integers or whatever. And now, clean data is really just the beginning, right? It is the beginning of the foundation for doing analytical data, right? So in order to answer all the business questions that we need to actually move the business, to understand how to evolve our business, there's much more than we need than just a data lake with some trustworthy data in it. But this is kind of the foundation to a lot of more modern concepts like the data mesh. The idea that data should have ownership as a first-class citizen in domain-bound teams and groups, and later have this as the foundation for creating more complicated things, right? Because once we have metadata that we can trust, once we have ownership, when we're fixing all the, let's call it third world problems that we have, then we're able to do much more smarter things. So if we talked about metadata-driven ingestion, then we can do something like metadata-driven processing. So essentially, once we know how the data looks in foundation and also later in the first source, we can automate also the creation of second derivatives, right? The analytical tables that we used for this and the joining of the data together. But we will do this on another time. And if you have questions, let's do it right now.